My dear students, so now today we are going to discuss the continuation of the coordination compounds, that is a nomenclature of coordination compounds. So in the last class, I already told you the rules which are given by IUPAC for the coordination compounds. Now we will give certain names, we will give the names according to their IUPAC. So we will give certain names to the different complexes. Generally, we will have a cationic complex or anionic complex, whatever may be, just we have to give a name for each complex. So let us see how we can give the name for a particular complex. So let us see this. So these are the rules I already told you in the last session. That is, if a coordination complex is a non-ionic, name should be written in a single word without any space. So that I have already told you in the last session. So go through that last video and we will continue the further examples. So these are all the rules. So, so let us start here. So see here, now we'll see some examples here. So let us start with the non-ionic complex. So these are the non-ionic complex. See here. So these are the non-ionic complex or neutral complex. So we will see what is actually the generally we will say. So first of all, I want to tell you one thing here. So here I want to tell you one thing here. See here. So if generally we can take complexes, these complexes which are two types. First one is ionic complex, ionic complex, and the second one is non-ionic complex, non-ionic complex. So what is the difference between these two here? So what is an ionic complex? Ionic means whatever the coordination complex, that must be a cation or anion. In case of non-ionic, this is also called neutral complex. This is also called neutral complex. So let us see the examples of this. So let us take a small example here. Let us take iron, which is coordinated with cobalt. And see here, this is one of the complex. So see here, there is no charge here, that is zero here. That means which is a neutral. You can take any compound like nickel, which is CO4, like this. This is also one of the complex, which is a neutral. There is no charge here. Now let us say in case of ionic complex. So let us take a simple example like this. NuCu, like this. See here. So let us take this example. Here copper is coordinated with 4 ammonia ligands. So what happens? Is it a charged complex or neutral complex? So is it an ionic complex or non-ionic complex? So definitely it is an ionic complex. Why? Because here there is no charge here totally, which is zero. But how you are saying it is an ionic complex? Why? Because here we have to see only the coordination complex. So you can observe here that you can easily understand here the coordination complex is up to this. So this is the total complex, but the coordination bonds are present only in this square brackets. So generally this Cu NH3 taken 4. So in this is only our coordination bonds. So the dative bonds, the coordinate covalent bonds are present only in the square brackets. So in outside of this Cl2, these are not coordinate covalent bonds. So we will give the nomenclature for this coordination sphere. So you can easily understand here. So the coordinate covalent bonds are present in this specific coordination sphere. So you must see the oxidation state of this coordination sphere. So what is the oxidation state of this coordination sphere? So what is the oxidation state of this coordination sphere? So how can we say how can we calculate the oxidation state of the sphere? So you can easily understand here. What is the oxidation state of chlorine? So that chlorine, which is generally the chlorine halogens are having -1 oxidation state. So here two chlorines are there. Two chlorines are there. That means -2. 2 into -1. So you will get -2. So here the oxidation state of chlorine, which is -2. And here +2. So if this outside of the sphere is -2, then this inside of the sphere which is +2. Why? Because it must be total which is 0. Total must be 0. Total must be 0 here. Then only the complex will be totally it satisfied it oxidation state. So you can understand here. This is our complex. So first of all, this is our complex. So you can easily observe that there is no charge. So totally it is 0. That means that if chlorine is -2 here, definitely it must be a +2. So now the +2 is for the particular complex. So this complex is our +2 complex. So +2, this is cationic complex. This is a cationic complex. That means this is a ionic complex. This is our ionic complex. So let us say one example, another example, so you can easily understand here. So I will take another example so that you can easily understand here. So let us take the complex like this: K3 FeCN6, like this. So you can observe here what is this complex? What is this complex? This is iron and this is our cyanide. So what is this complex? Is it an ionic complex or not? So you must understand that the total charge which is 0 here, there is no charge here. ఇక్కడ మీకు ఏం కనిపిస్తలేదు నాన్న, total charges you are not finding anywhere here. So you must understand here the total charge of this whole compound which is 0. What is our, where is our coordinate covalent bonds here? Only in the inside of the sphere. So inside of the sphere we need to understand the oxidation state of coordinating sphere. So K3 means first group elements are having +3 oxidation state. Here, sorry, first group elements are having +1 oxidation state. Here potassium having +3. So potassium ikkada 3 potassium atoms unnai. So the oxidation will be +3. So here it is +3 means this must be a -3. Then only the total will be 0. That means this complex is having the -3 oxidation state. So if it is having -3 oxidation state, then we can say that this particular complex is an anionic complex. So this particular complex is a anionic complex. So I will say some examples so that you can easily understand different complexes. So let us say I will write one example. So let us take this MnCO8. So is it an ionic or non-ionic or cationic or anionic? So you can easily understand here. Let us take some examples. FeCO5, K4 FeCN6, CO NH3 6 Cl2. Let us take some other example like copper NH3 taken twice. Then we take platinum. So let us see here. So I will tell you here, see here, what is an ionic complex, what is a non-ionic complex. So observe here, is it an ionic complex or non-ionic? So you must understand one thing here, that the total charge always must be 0 here, because there is no charge on each coordination sphere. So you are not finding any charge here. That means the total charge will be 0. Total charge must be 0 here. First of all, you should understand that. Then let us see what is the charge of the complex. So what is the charge of the complex? Let us see here. So let us see for the first let us see manganese. So what is the charge of this manganese? So you can see here there is no charge. So this is a coordination complex. So definitely it is a neutral complex, because the total charge of the complex which is 0 here. Next, here also you can see there is no charge here. So here this is also neutral complex. So in case of this, is it an ionic or neutral? So see here potassium is there. That means here +4 here. ఎందుకంటే ఒక పొటాషియం కి ఎంత నాన్న, పొటాషియం is having the +1 oxidation state. Here 4 potassiums are there, then it is +4. then it is -4. If it is +4 here, then definitely it must be a -4. Then only the total will be 0 here. So here the complex is having the -4. That means this is a anionic complex. This is a anionic complex. Now let us see here this. So here chlorines are there. Two chlorines are -2. That means here +2 here. That means this is our cationic complex. This is a cationic complex. Why? Because this complex is having the +2 oxidation state. Now let us see here. There is no charge here. That means the whole complete compound, complete molecules are present in the inside the coordination sphere. So it is a neutral. So this is our neutral, non-ionic. And here also you can observe here. This is also neutral here. This is also neutral complex here. So first you must understand which one is non-ionic or which one is ionic. If it is an ionic, again is it a cationic complex or anionic complex? So you must understand this thing also very much to give the names of particular complex. So let us see some example so you can easily understand all these things. So see here. So let us start with the non-ionic complex or neutral complexes. So let us start with the non-ionic or neutral complex. So how can we give the name for the neutral complex? Let us see the first one. This is FeCO5, and you must we will see first of all rules so you can easily understand all these things. So what are the rules for? So let us see for the first rule, which is if the coordination complex is a non-ionic complex. So first of all, you should understand these things here. So if it is a coordination complex is a non-ionic complex, then name should be given in a one word, in a single word without any space. That means you can easily observe here, which is here four carbonyl groups are there. So tetra, carbonyl, nickel. So here the oxidation state of nickel will be 0. So I will tell you how to write the ligands name and metal with charge. First of all, you should one thing here. You should see one thing here, the non-ionic complex. If it is a non-ionic complex or neutral complex, non-ionic or neutral, then you must give the names. You must give a name in a single word without any space here. Without any space you must give a name. So see here this, so there is no gap here. Tetra, carbonyl, nickel, 0, penta, carbonyl, iron. So there is no name here. So there is no space between each word. So if it is a non-ionic or ionic, you must you must write in a single word without any space. So this is the first rule. So we will see the further rules and we will give further names here. So let us see here. So let us see some examples. So let us see here. So what is the name of this pentacarbonyl iron 0? So first of all, you must understand one thing, how to write a complex name. So if it is a non-ionic, so write in a single word. Okay, that is good. So next, we need to see, understand, we need to understand that to write a complex name, first what should you write? First of all, you should write only ligand's name. So you must write ligands and followed by the central metal ion with its oxidation state. Then oxidation state toni rayali. So see here, first you must understand here, this is a central metal atom which is iron, and this iron is coordinated with 5 carbonyl ligands. So 5 carbonyl ligands. So then you must understand here, so we need to write the first, we need to give a name for this particular complex. So what you have to remember is one thing, you must write first ligand's name. So first you must write ligand's name followed by the metal. So what are the ligands here? So here 5 carbonyl ligands are there. So each ligand, so what you should give the name? So for the ligand's name. So if this ligand, here the carbonyl is our ligand, and if this carbonyl is a monodentate or bidentate, is it a monodentate or bidentate? If it is a monodentate, you must give the names as what you can give here: di, mono, di, tri, tetra, penta. Like this, you must give the names for the monodentate ligands. So if it is a bidentate ligand or polydentate ligands, you must give the names as bis, tris, tetrakis, pentakis, hexakis. Like this, you have to give the names. So you should understand here one thing here. First, you write the names. So write first of all, you should see the ligands. So if it is a ligand is monodentate, if it is a monodentate, simply you can write as tetra, penta, like this. You can easily write here. So you must see here the ligands are 5. So 5 means, and this CO is a monodentate ligand. CO is a monodentate ligand. So if it is a monodentate ligand, you can easily write as penta. If it is a not a monodentate, if it is a polydentate ligand, if it is a polydentate ligand, you can write as pentakis. Pentakis. So you have to write like this. But this is a monodentate ligand. So you must write here as penta. So penta carbonyl. So penta carbonyl. And then so you can easily understand here. So this is a neutral complex or non-ionic complex. So you must write iron as iron only. So you must remember these points, very important here. So once again I am telling you that. So if generally to write a complex name, first of all you must write ligand's name and followed by the మెటల్ అండ్ మెటల్ కి మనకు ఆక్సిడేషన్ స్టేట్ ఉండాలి. అది ఎంత ఆక్సిడేషన్ స్టేట్ అయితే అంత. దెన్ వి మస్ట్ సీ లిగాండ్స్ అనేటివి మోనోడెంటేటా బైడెంటేటా. సో ఇఫ్ దే ఆర్ మోనోడెంటేట్ then you must give names as di, tri, penta, tetra, like this. If it is a polydentate, you can give the name in bis, tris, like this. And then you must understand here one thing. So if it is a non-ionic complex or cationic complex, there is no suffix for the central metal ion. So I will show you once again this. So see here. So if it is a complex, so see here, if it is a non-ionic complex, then you can write in a single word without any space. Okay, this is very good. And see here, you can easily understand this. So next one you can see here. So if the coordination complex, so see here. So if it is a coordination complex, is an ionic complex. If it is a coordination complex, is an ionic complex. So if it is an ionic complex, so is it a ionic complex? Is it a ionic complex first? So definitely it is an ionic complex. So you can easily understand here, there is +4 is there. So here potassium is there. So potassium means, generally in case of potassium means what here? Potassium which is having +1 oxidation state. Here +1 oxidation state potassium, that means 4 potassiums are there. That means 1 +1 into 4. You will get the oxidation state as +4. So you can easily understand here the potassium is having here +1, but here 4 potassiums are there. So then it is a +4 oxidation state. Then if it is a +4, then the coordination pair will be -4 here. Why? Because the total charge must be 0. The total charge must be 0. You must remember these things. సో ఎందుకంటే ఇక్కడ ఎక్కడ ఛార్జ్ కనిపించట్లేదు కదా అన్న. ఇప్పుడు సల్ఫేట్ ఉంది, SO4 -2 ఉంది. అప్పుడు టోటల్ ఛార్జ్ ఎంత అంటే -2. ఎందుకంటే పైన కనిపిస్తుంది కదా అన్న. సో పైన కనిపిస్తుంది నీకు. ఇప్పుడు Br మైనస్ ఉంది. మైనస్ ఈజ్ ఎ charge like this. If it is NO2 minus, that means the total charge will be -1 like this. But in case of this, there is no charge here. You are not find any charge of this total compound. So first you need to understand that here it is +4 and then this must be -4. So this is our anionic complex. This is our anionic complex, which is an ionic complex. So if it is an ionic complex, first of all, the name of the cation is given first and followed by the anion. So see here. So if it is an ionic complex, so you must write the cation name and then followed by the anion. So the cation here, which is potassium. So potassium is our cation here. And the remaining the anion, which is FeCl6, which is -4. So here you must understand here. అంటే క్లియర్ గా చూడనా, ఇఫ్ ఇట్ ఈస్ ఒకవేళ అది డిసోసియేట్ అయితే ఎలా అవుతుంది అంటే 4 potassium plus FeCN6 minus 4. Like this, it will be dissociated like this. That means you can easily understand here the complex is having the minus 4 charge. Hence, it is a anionic complex. So first of all, there is a potassium which is a cation. So first name of the cation must be written first. So this is our potassium. So here 4 potassiums are there. No need to write the tetra potassium like this because we must give a nomenclature to the major coordination complex which are having a dative bonds or coordinate covalent bonds. So coordinate covalent bonds అనేది ఈ కాంప్లెక్స్ లోపలనే ఉంది కాబట్టి మన నేమ్ అనేది దీనికే ఇంపార్టెంట్. దాని బయట అనేది అంత ఇంపార్టెంట్ కాదు మనకి. So you can easily write as potassium hexacyano. Why? Because here 6 ligands are there. Hexacyanoferrate. Here the potassium is there, which is the first one. You must understand here. Why? Because here which is a cation here. Then followed by the anion. This is our anion. So the hence we have written like this. Now let us see the second case. So the second case see here. So this chlorine is there, which is having the minus 3 oxidation state. In the chlorine and minus 1 is a chlorine oxidation state. Here the chlorine which is minus 3 is there. That means here 3 chlorines are there. That means 3 chlorines means minus 3 is the oxidation state. Here which is a minus 3 oxidation state. That means here this will be our plus 3 oxidation state. Here it can be dissociated like this. So it can be easily dissociated into like this. CO, NH3, CO, NH3 whole bracket, that is plus 3 and 3 chloride minus. So this is the ionic, this is the ions which are produced. So here CO NH36 which is a cationic complex. So this is our anions which are chlorine. So which one is cationic here? This is the cation and this is a cation and this chlorine which is an anion. So remember that in a coordination complex, if it is an ionic complex, the name of the cation must be followed by the anion. So first of all cation. So this is our cation. So you must write this first one, then the chloride must be second. So see here we have written the first name up to here the complex name and the further we have written the negative, the anionic part. So the anionic part must be written in a last. So remember this thing. The cationic part must be right first, then followed by the anionic part. So anionic part must be written in a last. So you must understand these things. So let us see the continuation of this. So let us see here some examples. So if it is a, so you must understand here also. These points you must understand here. So if the cation is, so generally I already told you that the cation must be named before the anion. So first you must write always cation and then followed by the anion. Then in a naming of a complex, that means if a complex is there like this, if a complex is like this, it is a there. If this complex is there, when a naming of a complex, దీని నేమ్ రాసేటప్పుడు when naming of a complex, ligands are named first. ఇందులో 6 ammonia ligands ఉన్నాయి నాన్న. So you must write names of the ligands. So you must write names of the ligand here. So ligands are named first, and if ligands are named first and then followed by the metal ion. So ligands are named first and the metal atom or metal ion which is named last. So metal must be named last. So first here ammonia is there. First you have to write the ammonium part and then followed by the metal. So first if more than one ligand is there, then you must write in a alphabetical order as A, B, C like this. I will show you some examples. So next, after the metal atom, you must write the oxidation state and in a Roman numerals follows in parentheses. That means you can write here like this one, this is 2 here. So you must write these Roman numerals as 1 here, 2 here and 3 here. So you can see here 3 and 4, that is 5. Like this you must write the oxidation state of metal after the metal. So after the metal you must write the oxidation state. So these are the rules here. So next let us see here. So then the name of the anionic ligands ends with the suffix O. I already told you that chloro, bromo, iodo, hydroxo, like this many of the anions are having the suffix as O. Then generally like here you can see here bromo, chloro, cyano, hydroxo and oxo. This is fluoro. So you know that this names like this. Every ligand is having the particular O as a suffix. For the anionic part, they are only anionic ligands. So next, these are the names like this. They are having -2 charge like this: carbonato, oxalato, sulfato, thiocyanato, thiosulfato, sulfito. Like this, each ligand must be have the suffix as O in case of anionic ligands. Then if it is a neutral ligand like ethylene diamine, this is the neutral ligand. This is a neutral ligand. The ligand which is having the structure like this: NH2, NH2, CH2, CH2, NH2. This is the structure. This is the structure of ethylene diamine. It is a bidentate ligand which can give two lone pairs like this. This one it can easily give lone pairs, and this one also it can give the lone pairs. So ethylene diamine, which is a neutral, because there is no charge on each, there is no charge on any atom. So this is a neutral ligand. So in case of neutral ligands, you do not have any suffix. You can easily directly write like this: water as so ethylene diamine. You must write like this. But some exceptions are there. Water you don't write as water. You must write as aqua. Aqua. Then ammonia you must write as amine. So if it is NH3 is there, you must write like this: amine. So if it is NH2 is there, then you must write amido. Amido. So if it is NH2 is there, but here NH3 is there, you must write amine. If it is a carbon monoxide CO, you must write as carbonyl. If it is NO, if it is NO, you must write as nitrosyl. Nitrosyl. This is a carbonyl and this is the nitrosyl. So you must write these. These are the neutral ligands. You don't have any suffix here. Only the anionic part, which are chloro, bromo, fluoro, like this hydroxo. They are only having the suffix as O here. But in case of neutral ligands, there is no suffix. There is no suffix here. And then there are some cationic ligands are also there. But cationic ligands are very less. So I will tell you why the cationic ligands are very less. I will tell you later on. But see here that if it is a cationic ligand, then which is a nitrosonium, the suffix which is ended with ium, that is ium, the suffix NO2, nitronium, nitrosonium, hydrosonium, the suffix must be ium. So next, so let us see here. So next, if it is a complex, is an anion. If it is a complex, is anion. If this complex is an anion means, so you can easily understand here. So let us take a simple example: K3 FeCN6. Is it an anionic complex? Definitely it is an anionic complex, because the iron here, here we can write as +3 here, and we can write as -3 here. So you can easily understand here. So we are writing +3 here and here -3 here. So why? Because potassium is having 3 potassiums are there. So that means K3, and here -3 is there. So generally you must understand here, this complex is our anionic complex. So if it is an anionic complex, if it is an anionic complex, its name ends with the 8. So the name must be ends with the 8. Name must be ends with the 8. So what is the iron? Generally it is ferrum. So you must write the name as ferrate. Ferrate. You must write the name as ferrate. Like this, many complex as chromate, chromate, ferrate, nickelate, like this. You can write as 8 as a suffix. Every manganate, everything you must zincate, silicate, aluminate. So if the complex is anion, the name ends with the 8. So this is one of the example you can write. You must write as ferrate. So if the complex is a cationic or neutral ligand, then the metal shouldn't have any suffix. So if it is a complex, is a cationic or neutral. So let us take the iron complex only. Let us take FeCO5. So here you must write as pentacarbonyl, carbonyl iron. You must write here iron. So you must write iron. So why you are writing here iron here? So why we are writing here iron here? Why? Because it is a neutral. It is not a anionic complex. So you see here there is no charge here. There is no charge here. So if there is a no charge, that is a neutral. So if it is a anion, then you can write it as ferrate, but it is a neutral, so you can directly write as a iron. So this is a one of the rule, you must remember these things. Next, so let's see here, if it is an anionic complex, then the metal will have the names like this: scandium, as scandate. 1 minute. So see here, if it is a scandium, which is scandate, titanate, vanadate, chromate, manganate, ferrate, cobaltate. So it is a cobaltate and nickelate, cuprate, zincate. So like this, these are the if it is an anionic complex, you must write the suffix for the metal as ate. So you must write these things. So next, so let us see if it is an ambidendant ligand. This is also very very important here. So if it is an ambidendant ligand, ambidendant means, so see here. Here metal is coordinated with the nitrogen here. This exactly this and this. There is no difference between these two ligands. So this is also MO2 and this is also NO2. There is no difference between this one and this one. But the linkage with the metal is different here. So let us see here. Here this metal is linked with the nitrogen here, but here the metal is linked with the oxygen. So same ligand. There is only one ligand. It is a monodentate ligand. Monodentate ఎందుకు ఒకటే డోనర్ ఆటం ఉంది. ఇక్కడ నైట్రోజన్ డొనేట్ చేస్తుంది, ఇక్కడ ఆక్సిజన్ డొనేట్ చేస్తుంది. So this is a monodentate ligand, but the linkage is different here. That means, so for it, in case of first nitrogen is donating here, but in case of second, the oxygen is donating here. So such type of ligands are called ambidendate ligands. So in case of these ligands, so you must write the ligand name as, here if it is NO2, you must write as nitro and with a donor atom. Nitrogen donate చేస్తుంది కాబట్టి nitro అని రాయాలి. If it is ONO, you must write as nitrito O, because it is linked with the oxygen atom. So if it is SCN or NCS, so SCN, so SCN means generally cyanide. CN, simply it is cyanide. If it is S and thiocyanide generally. So if it is an anion, so you must write as ato, suffix O వస్తుంది. So it's thiocyanate here. So next, if it is NCS, that means it is reversed here. So generally it can give as a name isothiocyaneto. So this is a thiocyaneto and this is our isothiocyaneto. So these are the ambidendant ligands and you must write the linkage or donor atom. So you must write the linkage or donor atom. So next, let us see here. So if monodentate ligands are more than one, so see here. So this is also very very important here. If monodentate ligands are more than one, so use the prefix as di, tri, tetra, penta. So what are the monodentate ligands? So like chlorine, bromine hydroxy group are there, like ammonia. So whatever may be, water. So these are all pyridine. Everything is a monodentate, like it can donate only through one donor atom. So in if number of polydentate ligands are more than one, then use a prefix as bis, tris, tetrakis, pentakis, hexakis, heptakis, like this. You must write as like this. So generally these are the Greek letters. But if bidentate ligands are there, that is a polydentate ligands. So you do not use the word as di. So you must use the word as bis, tris, tetrakis, pentakis, like this. So then if number of different ligands are more than one, then write in a alphabetical order. So write in a alphabetical order. So like ammonia, aqua. So like this, what is the alphabetical order here? So as ammonia, aqua, bromo, chloro, cyano, nitro. So here ammonia is there. So first, what is the letter? You can see here alphabetical order means A will comes first and then after that B, C, like this. So ammonia, A, after A, then M is there. So here after A, which is Q is there. Hence ammonia comes first. After that aqua, water which is. Then bromo, chloro, cyano, nitro. Like this alphabetical order must be follows. Like for a polynuclear complex, for a bridged ligand, use the symbol mu as a suffix, sorry, use as prefix for each ligand. So for each ligand, you must use as mu as a bridged ligand. So I will say for what is a polynuclear coordination compounds. So let us see some examples here. So see here. So let us see these complexes as examples. So see here. So these are the non-ionic complex. So let us see from the first one. So you this is a non-ionic complex. So first you must remember that you shouldn't you should write in a single word without any space. So here we can first to write a complex name. So first we need to give a name for the complex. So we have to first write ligands followed by the metal. So first ligands are CO. That means you must write as pentacarbonyl. So here why it is penta here? Because it is a monodentate ligand. So you must use only the prefix as mono, di, tri, tetra, penta, hexa like this. So here 5 is there. So pentacarbonyl, iron. So here you do not use the word as suffix ferrate, nickelate, chromate. You shouldn't use like this because it is a neutral. It is a neutral. There is no charge. So you can simply write as iron. Iron, this is the zero. That's the oxidation state of this iron. So oxidation state total in the zero. Then what is the oxidation state of iron? Iron oxidation state in the yellow calculate just so you can easily calculate like this. So you can easily calculate here as iron. So what is the oxidation state of iron? So I don't know. So I'm writing X here. Then there are 5 carbonyl ligands are there. Carbonyl. What is the charge of the carbonyl ligand? So you must remember these neutral ligand. So what are the neutral ligands? Generally CO, NH3, H2O, NO, and these are all EN, that is ethylene diamine. So you must remember these things. They are neutral ligands. So they are having zero charge. There is no charge for them. So there is no charge. So here five carbonyls are there. So each carbonyl is having the zero. Each carbonyl is having zero as an oxidation state. So 5 into 0 is equal to total ఎంత నాన్న ఇక్కడ మళ్ళీ total 0. Then 5 plus 5 into 0, that is 0. Then 0. Then x is equal to 0. That means here the complex is having the 0 oxidation state and this iron is also having the oxidation state as 0. Hence here the oxidation state is 0 here. So in this way you can write the names of each complex. So see here. Here also see here the tetra 4 carbonyls are there. Tetracarbonyl nickel 0. Tetracarbonyl nickel 0. Here also same x plus 4 into 0 carbonyl ligand and then is equal to 0. Then x plus 0 is equal to 0. Then x is equal to 0. This the nickel is also having the 0 oxidation state. So here tetra ligand name first with tetra carbonyl nickel 0. You see here there is no gap between each word because they are neutral ligands, sorry, neutral complexes. So if they are neutral complex, you don't use any, you should write in a single word without any space. So see here next. See here, this is also neutral because there is no charge here. So the total complex is a, the charge will be our 0. So see here. So first of all, you must calculate the oxidation state here. So what is the oxidation state of this cobalt here? So here you must know that. So the total charge will be 0. That means here in this particular metal. So here cobalt is a metal. Maybe it may be +3. The ligands may be -3. So like this, the total will be 0, but it doesn't mean the metal is having the 0 oxidation state. Remember that always a metal is having the charge as 0 or positive. There is no negatively charged metal. There is no negatively charged metal. So see here, you can understand here, you will calculate the oxidation state of cobalt here. But you know that the total charge will be 0 here. So let us take first cobalt. I don't know. So I am writing X. Then here, what are the ligands here? 3 ligands are there. So 3 ligands which are NO2. So NO2, what is the charge of the NO2 here? So you must remember these things here. NO2 as a -1 oxidation state. Each halogen is having the -1 oxidation state. So remember these points, they are very, very important here. So you must remember these things. So NO2 as a negatively charged here. You can see the ligand charges also. So see here 3 into -1 because the this nitro group which is having -1 charge there plus 3. Next, how many are there? Next, ammonia ligands are there. So they are 3 into what is the charge of the ammonia ligand? That is 0 here. Just now only I told you that H2O, NH3, CO, NO, pyridine. So all these things, they are the neutral ligands. There is no charge for them. But in case of nitro and these halogens are having -1 oxidation state. They have a hydroxy group. So hydroxy group is also having the -1 oxidation state like this. So total in total mali 0. Then what is X plus 3 into -1 enta minus 3 plus 3 into 0, 0 is equal to 0. Then X minus 3 is equal to 0. Then X is equal to plus 3. ఇక్కడ 3 అటుపోతే ప్లస్ 3 అవుతుంది. యూ మస్ట్ రిమెంబర్ దట్ మైనస్ అటుపోతే ప్లస్ అవుతుంది నాన్న. ఒకవేళ ప్లస్ అటుపోతే మైనస్ అవుతుంది. సో యూ మస్ట్ రిమెంబర్ దీస్ థింగ్స్. సో ఎక్స్ మైనస్ 3 ఈజ్ ఈక్వల్ టు ప్లస్ 3. ఇక్కడ -3 ఉంది, అటుపోయేసరికి ప్లస్ 3 అయింది. సో హియర్ ద కోబాల్ట్ ద ఆక్సిడేషన్ స్టేట్ హియర్ ప్లస్ 3. సో రిమెంబర్ దిస్ థింగ్. అంటే దీని చార్జ్ ఎంత అంటే ప్లస్ 3. సో నైట్రోజన్ యాక్చువల్గా -1 గానా మూడు నైట్రో గ్రూప్స్ ఉన్నాయి అంటే -3 అన్నట్టు. సో +3 -3 ఇదేమో 0 ఆక్సిడేషన్ స్టేట్. సో టోటల్ ఏమైంది నాన్న? టోటల్ 0 అయింది. సో ఇన్ దిస్ వే we can write the nomenclature. We can give the name for each complex. So see here. So now you are getting the oxidation state of cobalt. So now we need to give the name for this complex. So here let us see first what are the ligands are there. Nitro here, ammonia is there. So this which one there are two ligands are there. So you must write in a alphabetical order. So first here nitro is there, here amine is there. Which one will comes first? So in alphabetical manner, ammonia will comes first. A first, then N. So we don't see the alphabetical address for try like this. So you must see only the ligands names. So you must see the alphabetical order for only ligand names. Here amine is our ligand, nitro is our ligand. So which one will comes from A or N? So amine will come first. So here triamine, 3, they are the monodentate ligands. So simply you have to use triamine, trinitro, and this is a ambidendant ligand. So you must write the linkage atom. If it is a ONO, you need to write the O as a linked atom. If it is NO2, you need to write the linked atom as N here. So N, cobalt as 3 oxidation state. So in this way you are writing the name of this complex. So see here also you need to write the oxidation state. So here how many, first of all, for everything to give a name, first you must do one thing, that so first you should fix the oxidation state of central metal ion, then you can give easily name here. So first of all find the oxidation state of this central metal ion. So total is 0 here. You are not here, the total charge will be 0 here. Let us calculate the oxidation state of this platinum. So platinum first I don't know, X. Then first of all I don't know, so I'm writing X plus 2 ammonia ligands are there. The ammonia ligands are having the charge as 0. So just now only I told you that ammonia, water, CO, NO, pyridine, they are the neutral ligands. There is no charge for them. So here 2 into 0 plus అన్నిటి కూడా యాడ్ చేయాలి. So again 2 chlorines are there. Each chlorine is having the -1 charge. Chlorine will have the -1 charge is equal to 0. then x plus 2 into 0, 0 plus 2 into minus 1, you will get a minus 2 is equal to 0. Then x plus 0 and x plus 0, that is 0, and plus into minus. So here plus into minus, minus, which is equal to 0. That is x minus 2 is equal to 0 here, and x is equal to plus 2 here. This is the oxidation state of the platinum. That means here which is having the oxidation state as plus 2, and these are the neutral which is 0, and here two chlorines are there. Generally one chlorine which is minus 1, two chlorines are minus 2, and you can easily understand here plus 2, 0, minus 2, total will be 0 here. The charge of the oxidation state of the platinum which is 2 here. So you must remember these things. So next, so so see here. So you can write the name of this particular complex. So what is the name of this particular complex here? So first, how many ligands are there? Ammonia is one ligand and chloro is another ligand. So see here. So here ammonia is one ligand and chlorine is another ligand. So diamine. So first amine will comes first. After that chloro. So diamine. They are the monodentate ligands. So hence we have to use as the word prefix as di. Diamine, dichloro, platinum, and the two as a oxidation state. So you must remember these things. This is a non-ionic complex. You must write in a single word without any space. So I'm not giving space at anywhere. So remember that thing also. See here, this is a big complex. So you must remember this thing also. So see here, how many ligands are there? One, two, three, four. They are all monodentate ligands. So you must write like there are only one ligands are there. So you must write in alphabetical order. So first amine comes first, then bromo, then amine first A, then B bromo, then chloro. Sorry, this is chloro. Then pyridine. So this is a pyridine. This is also a neutral ligand. So this is also a neutral ligand. And write then platinum and find the oxidation state. So what is the oxidation state here? I don't know platinum, so I'm writing X. And a chlorine which is having the oxidation state as -1. Then bromine is also having the oxidation state as -1. Plus ammonia is having the oxidation state as 0. Pyridine is also having the 0 oxidation state. Then total will be 0 here. X -1 here first, and then again -1 here, and again plus 0 is equal to 0. Then x -1 -1, then you will get x -2 is equal to 0. Then x is equal to plus 2, which is the oxidation state of the platinum. So in this way, I will write the names of different complexes. So this is the nomenclature for the non-ionic complex or neutral complexes. Now let us see the nomenclature for the cationic ligands or cationic and non-ionic ligands. So these are the cationic ligands. So they are the cationic ligands, so cationic complexes. So observe here. So here you can easily understand that these are the, first of all, these are all ionic complex. So if they are ionic complex, you can write, you do not need to write in a single word. So you can give a space, because they are ionic complex. So see here, is it an ionic complex? First of all, you need to understand that they are the cationic ligands. They are the cationic complexes. So see here. So here chlorine is there. That means here -4. Then it is +4. So okay, it is a cationic complex. Here chlorine is there. That is -1. Here that means it is a +1. This is also cationic complex. And here +1 is there. So directly it is a cationic complex. Here there is chlorine is there. That means again -2 here. Again +2. This is also a cationic complex. Here this is sulfate, this is a -2 oxidation state. Here +2 oxidation state. This is also cationic complex. So let us see, give the names of these complexes. So let us see the first one. What is the oxidation state? So what is the oxidation state here? I don't know, so I'm writing X. Plus 6 ligands are there. 6 ammonia ligands are there. They are having the 0 oxidation state. So first you must write one thing here. The chlorine which is having the oxidation state generally -1. All the halogens are having the -1 oxidation state. So here -1 is there. Here chlorine are generally having -1. But there are 4 chlorines are there. That means here 4 into -1, you will get -4. If it is a -4, the cation of the complex, the charge of the complex will be +4. Then only the total will be 0 here. So here, what is the complex charge here? Only +4. So you can calculate the oxidation state like this. X plus. I don't know the oxidation state of platinum, so I'm using X. And then 6 ammonia ligands are there. NH3, 6. Then see here. So we completed up to this. The complex, the coordination sphere is completed up to this. So first one platinum X and the NH3, there are 6 ligands are there. So 6 into 0 and which is equal to +4. Here the oxidation state, the charge of the complex which is +4 here. That means see here X plus 6 into 0, then you will get X plus 0, then it is equal to +4 and then X is equal to +4. This is the oxidation state of the platinum. Here, see here, 4 is the oxidation state of the platinum. So here you can write the name as hexa. 6 ammonia ligands are there. 6 amine platinum 4. Sorry, I have not written here, but you must write here chloride also. So I already told you that in case of ionic complex, you must write the cation name first, then followed by the anion. So here the cation is our complex and the anion is our chloride. So you must write here as chloride. So here hexaamine platinum 4 chloride. This is the name of the particular complex. This. So next one, let us see here AgNH3Cl. So here what is the name of this complex? So first of all, chlorine. First of all, find the oxidation state. So you can easily give the name like this. Chlorine, which is -1, then it means the complex, the charge will be +1. So find the oxidation state of silver. Silver, I don't know, I'm writing X. So again, 2 ligands are there, 2 into 0, they are the neutral, then which is equal to +1. And then X is equal to +1. Why? Because 2 into 0, 0, X plus 0 is equal to +1, then X is equal to +1. So that means here Ag is also having the oxidation state as +1. So here, see here, I'm writing here +1 also here. So diamine, two ammonia ligands are there. The ammonia ligand can write as a amine, diamine silver 1 chloride. So chloride you must write in the last because it is an anion. So you must write the anion cation first, then followed by the anion. Cation first, then followed by the anion. So next, see here. So here which is so first of all find the oxidation state of chromium here. So I don't know, so I'm writing X. 4 water molecules are there. Water molecule is a neutral ligand plus 2 into chlorine is there. Chlorine which is having a -1 oxidation state. And the charge here you can observe here, this is +1. So that is +1 oxidation state. The complex. And you can find the oxidation state like this. X plus 4 into 0, that means 0 here. Then 2 into -1, that is -2 is equal to +1. Then X minus 2 is equal to +1. Then X is equal to +1 +2. Then the total will be +3. It is the oxidation state of the chromium. It is the oxidation state of chromium. It is the oxidation state of this chromium which is in the +3. So see here. అంటే దీనికి +3 అంటే చూడండి ఏం లేదు క్లోరిన్ కి ఎంత -2 అండ్ దీనికి ఎంత +1. So you can easily understand these things here. సో అది బయట ఉంది, సో ఇట్ ఈస్ ఈక్వల్ టు 0. మనకు టోటల్ గా 0 కావాలి. సో హియర్ టెట్రా aqua. So here 4 water molecules are there. Tetra aqua dichloro chromium chromium 3. So chromium 3 and you must write here as ion. Ion and రాయాలని ఎందుకు ion అంటే here there is a charge here. So there is no chlorine, there is no bromine, there is no something. So you must write as the ion because it is an ion. It is a cationic complex. So you must write as a ion here. Then see here. So first of all, this is also cobalt. So actually this is not CO. This is CO here. This is a cobalt. So this is a cobalt here. So see here. So find the oxidation state of this cobalt here. So first of all, X plus 3 ammonia ligands are there. 3 into 0 plus 1 water is there. So 0 plus 1 chlorine is there, -1, which is equal to, and